This video is going to be about how to solve and graph simple inequalities. So first we're going to just kind of review for graphing inequalities. First of all, inequalities are, there we go. Sorry about that. Inequalities are like, less than, greater than, less than or equal to, and greater than or equal to. So we are going to use whenever we graph them on our number line, and we use dots and shading to graph them. So we are going to use a closed dot for greater than or equal to and less than or equal to symbols. We are going to use an open dot for greater than or less than symbols. So if they have the equal to, then the dot has to be filled in. So a dot like this. If they don't have the equal to part, then it's an open dot. Just like that. Okay? And then we talk about interval notation. So intervals are, let's say the solution is all the numbers between 1 and 5. So we're going to write that interval, and it's either going to have parentheses or brackets or a combination of them. So parentheses indicate that that a value is not included, and parentheses go with open dots. And then brackets mean that something is included, and they go with closed dots. So this doesn't make a lot of sense to you as we just read it right off the paper, but as we do some examples, it's gonna make a lot more sense. On these first couple of examples, we don't have to solve anything. This is just learning how to graph things on a number line and how to write them in interval notation. So let's start with x is greater than or equal to 8. And in case you have trouble remembering greater than or equal to signs, when I was little, I was taught to think about this as an alligator's mouth. And the alligator is always going to eat the bigger meal. So the alligator is eating the x. So that means the x has to be bigger than the 8. And down here, the alligator is eating the -1. So -1 has to be bigger than a. So that might be very elementary, but that's how I was taught and I have always remembered. So this says x is greater than or equal to 8. So the first thing we're going to do is we're going to put 8 in the very middle of our number line. And then we're going to go up from 8 and down from 8. Now we have to figure out what kind of dot we're going to put on 8. Okay, so this says greater than or equal to. So if it has an equal to, then we have to use a closed dot. Now, in examples and stuff, you're going to see this on the number line, but let's use gray for whenever you're writing with your pencil. It's harder to see that whenever you're just writing on a pencil and paper, so you're welcome to graph it above the number line and then have, your line go however you need it to. But for examples, I'm going to put it on top the black number line. Okay, so anyway, now this says x has to be greater than or equal to 8. So it has to be bigger than 8, and x can be any number bigger than 8. So to graph this, we're going to draw a line all the way to the end of the number line and then draw an arrow on the end. Because any number in the whole wide world that's bigger than 8 can be x. Okay, so this is our graph. Now we need to write this in interval notation. And the way that I like to do interval notation is I like to read my graph from left to right. Okay? So my graph starts here with a closed dot. And if we have a closed dot, we use a bracket. Parentheses are for open dots. Brackets are for closed dots. Okay, and that bracket, that closed dot, is at the number 8. Then we put a comma. So my graph just goes and goes and goes, and then at the end of my graph, I have an arrow. So this arrow means that goes to infinity. So we are going to use this symbol, and it's like a sideways 8 that means infinity. And anytime you have infinity in your answer, you always use a parenthesis. So infinity always gets a parenthesis. And that is your interval notation. And this tells us that the answer, the value of x, can be anything from 8, including the number 8, the bracket tells us it includes it, all the way to infinity. Okay, so let's look at the next one. It says a is less than -1. So the first thing we're going to do is put -1 right in the middle of our number line. And then we're going to go up from -1. We're going to go down from -1. Then we look at our sign. This is less than, but it does not have an equal to symbol. So this gets an open dot. We do not fill it in. And that tells us that -1 represents a boundary for our answer, but it doesn't actually include -1. -1 is not allowed to be a value of a. Now, since a has to be less than -1, then that means it includes the numbers that are smaller than -1. So we're going to draw our line all the way to the end of our graph, and we're going to put an arrow on the end. Then we're going to write our answer in interval notation. So once again, we have to read our graph from left to right. So on the very left of my graph is this arrow. And arrows mean infinity, but this arrow points left. So a left-hand arrow equals -infinity. And infinities always get parentheses. Okay, so down here is -infinity, over here is positive infinity. So we need to remember that. Then we put a comma. So all this stuff in the middle happens, and then we end right here. And this is at -1. And -1 has an open dot, and open dots mean parentheses. So this interval notation tells us that our number can be anything all the way to -infinity, all the way up to -1, but it cannot actually equal -1. All right, so let's go look at some more. Now we actually have to solve some inequalities. So to solve an inequality, you follow the same rules as you would an equation, but we will have to flip the inequality symbol if you multiply or divide by a negative number. Okay, so we'll work through number 3 and see what that looks like. So the first thing that we want to do is we want to get our variables on the same side. So we're going to subtract 7v from both sides. That's going to give us -2v plus 1 is greater than -17. Now we need to subtract 1 from both sides. That gives us -2v is greater than -18. Then we're going to divide both sides by -2. But we are multiplying or dividing by a negative. So that means we have to flip our symbol. So we're going to get our -2's here cancel, and we're going to get V is less than. So we flipped that sign, +9. So that's our answer in inequality form. But now we have to actually graph that inequality. So remember, we start with a 9 in the middle, go up from there, and then down from there. And then we're going to look at what type of symbol we have. It is not greater than, or it is not equal to. So we use an open circle. And V is less than 9. So that is the numbers that are smaller than 9. So it's going to go this direction. And I'm going to use this opportunity to teach you a little trick. As long as your variable is on the left side of your inequality, then whatever direction your inequality symbol points, that's the direction that your arrow on your graph will point. Okay? So that's just a little trick that you can use in the future. But remember, your variable has to be on the left side of the inequality for that to work. So now let's write our interval notation. So the left end of my graph is an arrow. Arrows mean infinity. This one points left. That means negative infinity. And infinities always get parentheses. Then we go till we get to here. And that is at the value 9, and it is an open dot. Open dots mean parentheses. So that is our answer for number 3. Let's look at number 5. First, we will distribute. So we have 12p plus 52 is greater than -8 plus 4p. Then we want to get our variables all to one side. So we'll subtract 4p from both sides. We're going to get 8p plus 52 is greater than -8. Then we'll subtract 52 from both sides. We're going to get 8p equals -60. Divide both sides by +8. And, oh, I put an equal to sign. Don't make that mistake. Okay, that's not equal to. It is greater than. Okay, divide both sides by +8. And we get p is greater than -60 over 8 reduces to -15 over 2. Okay, so we have a fraction this time. Let's take a look at what that looks like. So we're going to put -15. Well, if I could get my pen to work here. All right, we're going to put -15 over 2 in the middle. And what we're going to do on either side is we're going to change the numerator by 1. So we're not just going to go to the next number or whatever. We're going to change the numerator by 1. So this one is going to be -14 over 2. But -14 over 2 actually equals -7. So we're going to label that -7. Then we'll get -13 over 2, which doesn't reduce. Over here, we're going to go -16 over 2. But wait, that equals -8. And then -17 over 2. Okay, so this is what our number line looks like whenever we have fractions. You make sure that you reduce the ones that reduce, but otherwise you just change the numerator by 1 in each direction. Okay, so let's look at our inequality now. We have P is greater than negative 15 halves. So it's just greater than, it's not equal to. So we'll use an open circle. And since P is on the left, we can just know that since it's greater than, and that greater than points right, that our arrow on our graph is going to point right as well. So this is our graph. Isn't that beautiful? Okay, so now for interval notation. Our graph starts here. Open circle means parentheses. And that parenthesis, or that open circle, is at negative 15 halves. And then it goes all the way to an arrow. And this one is on the right side, so that means positive infinity with a parenthesis, because infinity always gets parentheses. Now, number 7. We're just going to keep rocking through these. We've got this one and 2 more examples after that. Okay, so distribute. 24x minus 27 is greater than 24x plus 4. Let's move all of our variables to one side. And those cancel, but hey, these cancel too. And we learned about these special cases when we talked about solving equations. Now we're going to learn about them in solving inequalities. So our variables disappeared completely. So we have to ask ourselves, is this statement true? Is negative 27 greater than 4? And the answer is no, it's not. So, since this statement is not true, our answer is no solution. And so for your graph here, you just don't fill out anything. You don't have to put anything on there because there is no solution to this problem. And that's allowed. It's allowed to be no solution. That's okay. Okay, let's try another one. Distribute. 8 minus 14r minus 21 is less than or equal to 3r minus 30. Okay, so I'm gonna, hang on. We gotta combine like terms on this side first. So 8 minus 21 is negative 13 minus 14r is less than or equal to 3r minus 30. So I'm going to move my variables to one side. So those will cancel, and we get negative 13 is less than or equal to 17r minus 30. Add 30 to both sides, and we're going to get 17 is less than or equal to 17r. Divide both sides by 17, and these 17s turn into a 1, so we just have r, and then 17 over 17 equals 1. Okay, this can be a correct answer, but remember that our trick that we learned about which direction to point the arrow on the graph requires that our variable be on the left side. So if you ever have to switch the sides, you have to act like this is a mirror. Okay, so here's our pretend mirror that we're going to have. So when you flip this across the mirror, we're going to get r is greater than or equal to 1. So remember what I said about the alligator eats the bigger sandwich or the bigger meal? Here the alligator is eating the r. Here the alligator is still eating the r. Okay, so that's how you know that you flipped it correctly. So this is actually what we're going to use because then when we graph it, it's easier to graph. So our answer is r is greater than or equal to 1. So we put a 1 in, go up from 1 and go down from 1. And this is greater than or equal to, so that gets a closed dot. Then, since we put the variable on the left side and this inequality points to the right, we know our arrow is going to point to the right. And there's our graph. So then we do interval notation. The first thing here is a closed dot. Closed dots get brackets. That closed dot is at the number 1, and then our graph goes and goes until it hits this arrow. Arrows mean infinity, and infinities always get parentheses. Okay? We have one more example. Okay, we're going to distribute this. Remember, that's like a -1. So we have 11x minus 4 is less than or equal to 6x minus 3 plus 5x. Then we want to combine like terms on each side. 11x minus 4 is less than or equal to 11x minus 3. Then we're going to get our variables all to one side. And you'll see that once again, our variables all cancel. And we're left with -4 is less than or equal to -3. So, is this true? Is -4 less than -3? Less than or equal to? The answer is yes. -4 is less than -3. And so, since there are no variables in this and the statement is true, then our answer is all real numbers. So when you have all real numbers, you actually are able to graph this. So let's just use 0 as our starting point, because we need to label it somehow. And if we have all real numbers, we're going to have arrows on both ends, and the whole thing, is going to be our graph. And then our interval notation, we have an arrow on this end, so that's -infinity, and an arrow on this end, +infinity. So this is what your interval looks like for all real numbers. And the last thing I want to talk to you about is something that you won't work with a lot in this class, but it is something worth introducing in case it were to pop up somewhere. Like, if you're a junior and you're going to take the ACT, like maybe this would be there. If you're a senior and you have to take any placement tests for like career stuff, like I don't really know, this might appear somewhere. But in case you ever have to see this, this is called set notation. And here's how we write it. So x is greater than 5 is the interval we're trying to write. And so for set notation, you have these squiggly brackets that are hard to make. And then x, and then you have a bar, and then you have x greater than 5. And I'm going to tell you how to read this, because that's kind of what this means. Is the set of numbers. So these two squigglies mean a set. So the set of numbers, x, and this x means that the set is called x. So the set of numbers x such that this line means such that x is greater than 5. Okay, so this means that the answer is the set of numbers called x as long as x is greater than 5. And I know that's kind of weird. It's odd to like read it that way. But you may see this in the future, and I just want you to kind of have somewhere tucked in the back of your mind you've seen it before. So that's all I have for you for today. Thank you all for listening.